Good day, folks. Welcome to my YouTube channel. If you're new here, welcome, and please don't watch my videos without subscribing. And those who are not new, the returning subscribers, welcome back. Continue doing the right thing. Watch my videos till the end. Don't skip the ads, and share with your friends and families. Of course, like the videos, leave some comment. Thank you for the support, guys. We are on 3,000 and some old subscribers. It is all because of you. Today we are doing the September 2024, the Western Cape question paper. It's paper 1 and it's MCED district. It's a Metro Central Education District in the Western Cape. So we're going to start from the question 1 up until the end. But what I've noticed in this paper, there's no electrodynamics, which is the second last question, which is before the last question, which is the electrostatics, but it's out of 150. All right, let's cut the chase. Question 1, the multiple choice, right? It says a wooden block pulled up a rough inclined surface using a rope. The wooden block moves at constant velocity. So one thing that we need to know, when something moves at constant velocity, the acceleration is 0, the F net is equal to 0. That means the forces are balanced there. Let's look at the option. It says this means that there is no acting force. There are no forces acting on the block. That's incorrect. There are forces that are acting on the block, but the sum of them is equal to 0. No vertical forces acting on the block. That's incorrect. There are vertical forces acting on the block. Only gravitational force acts on the block. That's incorrect. That's obvious. The sum of all forces acting on the block is equal to 0. That's the answer there. Right. Now let's look at this question 1.2. It says a mass of an object on Earth is represented by that. So an object, it has that mass on Earth, right? It says which one of the following represented the mass of an object on a planet, which is not Earth, another planet that has a twice mass of the Earth and half mass of the radius, half the radius of the Earth. Now, one thing that you need to know, when an object is in any planet in the universe, the mass does not change. Right? When the mass does not change, that means the only thing that changes in an object is the weight, right? In the universe. So from planet to planet, what changes? The weight. The mass doesn't change. Now the question, they said which one of the following represented the mass of an object on a planet. So in any planet, the mass of an object, it won't change. For the fact that the mass of this object is x over g, it will be x over g. It won't change, right? So the answer here is B. Right, so these are not the option. 3. It says a ball of mass m is projected vertical upwards from the ground with an initial velocity v. So we have ball A. We are told it has the mass m and its initial velocity is 0. It is v. So let's have a drawing of that scenario. This ball is projected upwards, right? Okay, let's finish. It says a ball A rises to the maximum height above the ground. So this ball is projected from here with an initial velocity v, and of course it reaches the height h, right? And it reaches that height h with a final velocity that is going to be 0, right? Now it says a ball B with a mass of half m is now projected vertically upwards with an initial velocity 2v. So there's another ball, which is ball B, with the same scenario, but now the velocity that it was projected by, it was initially it's 2v, it's a double of the velocity, but the mass is half, right? Now, what is going to happen now? It says ignore the effect of friction. In terms of h, to what maximum height does the ball B rise above the ground? We do not know how much is the height for ball B to rise above the ground as compared to the ball A. Now, what do we need to do? We need to find the height of ball A, right? When we find it, the ball of A, the height of ball A, we're going to compare with the height of ball B. The only thing we know, the height of ball A is just h. It's just h. But what is that h amounts to, right? So we're gonna start with ball A, and then we're gonna use the formula that says Vf square V initial plus 2 delta y, right? So why are we using this formula? Because we have the final velocity for ball A, initial velocity, we have an acceleration, and we're looking for the displacement, and we're going to choose up as positive. That means our gravitational acceleration will be negative. So let's substitute. So final velocity is 0, initial velocity is v squared plus 2a, and the acceleration is going to be negative, and our height is h, right? So then we're going to have this is going to be v square. Okay, let me take the v square to that side to make things easy. It's going to be negative v square and negative 2a h, and then we're looking for what here? We're looking for h, right? We're going to divide by negative 2a, and then the negative will cancel, so we're going to have h is equal to 1. Okay, let me put it this way. It's gonna be v squared 2a, right? So this is the height for ball A. This is the height for ball A. The height for ball A is this. But if you're looking at this, is half v squared divided by half of v squared divided by A. Now let's look at for ball B. For ball B, we're doing the same thing. We're using the same formula because we have similar quantities there. We substitute. The final velocity of ball B is going to go up again. It's going to be 0 and reach the maximum height. And then the initial velocity, we're told it's 2v. So it's 2v squared plus 2. The acceleration, it's negative. And the height, the displacement is height. And then this is going to be 4 is going to be 4v squared. So when we take to that side, it's going to be negative 4v squared equal to negative 2ah, and then we do the same thing. We divide by negative 2a both sides, and then the height here, it's gonna be this negative and negative will cancel. It's gonna be 4 divided by 2, it's 2. It's 2v squared a, right? So now we have these two. So in this one you have a half, in this one you have a 2. So the what is the difference between half and 2? So this one, this height, if you're looking there, from half, let me put it this way, from half to 2 you have to move 4 times. You have to move 4 times by the half. That means the height of B is 4 times than the height of B. The height of B is 4 times the height of A, because from half to 2 you move 4 times by half, which is it's 4 times. So the height of B is 4 times bigger than the half of of ball A. So the answer here, it won't be this, it won't be that, it won't be that, it will be D. I hope it makes sense, guys. Right, 1.4, it says an object with a mass m is moving at a constant velocity v and collides head-on with an object of mass 2m moving in an opposite direction at velocity v. Right, immediately after collision, the smaller mass moves at the velocity v in the opposite direction and the larger mass is brought to rest. Ignore the effect of friction, refer to the diagram below. So these are the objects. This is before collision. This object m was moving in that direction, which is that direction is positive. That direction is positive. This is the initial velocity, So this is before collision, and this one is going to be negative and this one is going to be positive. And then when they collide to each other, the object m, it moves in the opposite direction where it comes from, which is, this is the final velocity, which is negative. And the object 2m, it goes to rest. So you can see here that it is a before and after collision. Now it says which one of the following regarding the momentum and the kinetic energy, right? Guys, if you look at this type of collision here, the momentum is conserved. So our answer here, it will be this, not that, not that, not that. Our answer here, it will be not that and that. So our answer is between that. The momentum is what is conserved. Now looking at this type of collision here, if you're looking at this type of collision, it's inelastic collision, because object m, it turns back with the same velocity, so there's no change in velocity. Do you see? The velocity is the same. And if you look at object 2m, its velocity, it was v, now it becomes what? 0. So that means that the velocity there's a change in velocity there. So that means the velocity is not conserved. The kinetic energy is not conserved there. So the answer there, it will be C. So it's not conserved. The total kinetic energy is not conserved there. So the answer there is that one. It can be that one. So our answer there at 1.4 is C. 1.4 is C. I hope I make sense, guys. Even by calculation, let me show you by calculation. Maybe just the theoretical doesn't make sense. So let's say the total kinetic energy before, so it will be this kinetic energy before, so it will be half m, and the velocity of m, it's just v square plus, and then the velocity of this one, it's half 2m times what? V square, right? So it's going to be half mv square. In this, it will be m v square, because half times 2, it's 1. So it's going to be half plus 1, it's going to be 3 over 2 mv square, right? That's the total kinetic energy before. Now let's look at the total kinetic energy after. So it's going to be half mv square, because the mass is m and the velocity is v square, right? And then for object 2, this one is going to be half 2m, and the velocity is what? Is 0. So what is remaining? It's that. So if you're looking there, the total kinetic energy, they are not the same, they are not conserved, so the momentum is conserved. That's why. So that's why the answer is C. 1.5, it says the graph below represent a constant force acting on an object over a displacement. So it's like you are pushing an object here by a force, and then there's a displacement. You displace this object from here to here. right? um come on. So you are displacing it from there to there, this object of mass there. So that's what it means there, right? It says which, okay, we're given the graph. It says the force and displacement graph in the same direction. If you look at this, this is the force and this is the displacement, right? And the area under this curve, guys, you can this is will be your breadth, and this will be your length. So if you calculate the area under that, the area is length times breadth, which is our length here is what? It's displacement, and our breadth is the force, right? Is the force. So we know the force times displacement cos theta, and when cos theta is 0, that will be 1, that will become f change in x cos theta. So the area under this curve, guys, the area under this curve, so it will be 1 here. So the area under this curve, guys, the area under this curve represent what we call, what is that? It's the work. So the area under this curve represent what? Work. So it says here, which one of the following statement can be deduced from the graph? The gradient of the graph represented the work done by the force. So here, looking at this one, this curve, there's no gradient. The gradient is 0, so it cannot represent the work done. The gradient of the graph represents the kinetic energy. It cannot represent the kinetic energy because the gradient there is 0, because do you see the line is linear there, so the gradient is 0 there. The area under the curve represents the net work done by the force. That's correct. It says the area under the graph represented the power dissipated by the force. No. So all the time, guys, if you have a force versus displacement graph, the area under that curve, it will represent what? The work done. And if you're looking at the graph here, the force is constant. When you push this object, you are doing work from there to there, and the force that you are exerting there is constant. Do you see? The force is constant, and there is a displacement there. It's displaced from that to that, so there's an increase in displacement there, and the force and the displacement are going in the same direction. That's why the cos theta is 0, which is going to be 1. So the answer there is C. Right, 1.6, it says a car travel at constant velocity along a horizontal road. A constant frictional force acts on the car during the motion. Which one of the following statement about the power dissipated by the engine of the car during the motion is correct? The power is, right? Now, this card says it moves at constant velocity, right? And there's a constant frictional force that is acting there. So it says which one of the following statement is dissipated by the power dissipated by the engine. So guys, if the power that is dissipated by the engine is then average power is equal to force, which is the force of an engine multiplied by the constant velocity. So if the velocity is constant, the power of an engine will be the power. If the velocity is constant and the force by the engine, it will be constant as well, and the force will be constant. So it won't be 0, it won't increase, it won't decrease, it will be constant. I hope I make sense there. It says a light reaching the earth from the galaxy moving away from it is shifted towards, right? So this is a key here. It says light reaching the earth from a galaxy moving away. So when the galaxy moving away, That is what we call, let's say, redshift, right? When the galaxy is moving away, it's a redshift. What is a redshift? Even the word redshift, it represents the what? The longer wavelength, wavelength, and and shorter and lower frequency, and lower frequency. Okay, let's write it here. And lower frequency. So if the galaxy is moving away, that's what we call it's an expansion. The universe is expanding, right? When the universe is expanding, that's what it's a redshift. So the redshift is associated with the longer wavelength and the lower frequency. So it says the light reaching the earth from the galaxy moving away from the shift from it, and it shifted towards the what? The longer wavelength. It can be a greater velocity, higher frequency, because it's a lower frequency and a longer wavelength. So the answer is longer wavelength and not a shorter wavelength. The shorter wavelength, it's the blue shift. These two are the blue shift, right? And these two are a blue shift, right? Okay. Now let's go to 1.8. The answer there is C, guys. The two charges, which is 2 nanocoulomb, positive 2 nanocoulomb and negative 2 nanocoulomb, are located in the straight line. S and T are 2-point charges that lies on the same straight line as shown in the diagram below. Right, if you look here, here's a straight line. It has the positive charge and the negative charge, and we have points there, right? We have points there, and yeah, it says which one of the following is correctly represented, represents the direction of the resultant of electric field at S and T. Right, right, guys. These 2 points here, which is the T and S, that they experiencing the electric field from these two charges, right? And their directions and the magnitude are different, right? All right. Now, what are we going to do here? We're going to look at the net or the resultant electric field that is experienced by S due to this one and this one, which means the net electric field that is experienced by S that comes from this one and this one, these two charges, right? One thing that you need to note, this is positively charged. So when it's positively charged, the electric field lines will go away, will move away, right? Like that. But we're going to focus to the electric field that is linear, to that is what that is in the same plane with the S. Yeah, that is in the same plane with S. So this electric field line will push point S to that direction, right? We'll push it to the right. And then let's look at what is this charge is doing there. So we know this one is a negatively charged. The negatively charged, the field lines are going towards. They are going towards. So if you're looking here at these two lines, this line, the field lines of this one will push S to the right, and the field line of this charge will pull the point S to the right as well. So the net of this, it will go to the right, right? Basically, it will go to the right. So the answer here is right. So it says the direction of the resultant force of at point S, it will be right. Right. So the possible answers there is between these two. So we'll see which one it corresponds to the other. It says the direction of the resultant resultant electric field at point T. Now let's focus on T. Let's look at T. T the resultant electric field of T, that is due to this one and this one. Let's look from the positive charge. The positive charge field lines, it will move to that direction, so we'll push T because this is positive, so the field lines will go away, away, away. So we'll push T to the right, right? So we'll push T to the right, and the field line, let's look at the field line. Let me use another color. Let's look at the field line of this now, this negatively charged to T. We know the negative charge, the field lines are going towards, right? Are going to go towards. So now, remember, this is far. The electric field that T experiences from the positive charge is coming from the long distance, so it's pushing it from a longer distance. So the longer the distance, the shorter the electric field, because the distance and the electric field are inversely proportional. Longer distance, the shorter the electric field. So the electric field that is experienced by T from the positive charge is smaller than the electric field that T experiences from this one. So this one is going to pull it to that direction. The negative charge is going to pull T to the left. So the answer here, because the bigger the electric field between these two, it's this one. Because this one is coming from a shorter distance, this one is coming from a longer distance. So the shorter the distance, the greater the electric field. So it's going to go to the left. So the answer here, it's left. It's left, not right. So the answer here is what? Is A. So the correct answer here in 1.8 is A. I hope I make sense, guys. There are so many ways to do that. Let's look at another option that will confirm that, maybe if you didn't understand that. Now, this point will take as the positive. This point are the positive test charge, right? So what is happening here when we first look at T, the net electric field that is experienced by S. So this one is positive as well, so it will repel. This positive charge will repel S to that direction, to the right, and then this one is negative. Since it's negative, it's going to attract this one to that direction, so it's going to go to the right. So that's why it's right. So the net is going to be right there. When you add these two, will give you that longer one, which is right. Okay, let's remove that. Now let's look at now let's look at the T. So this one is positive. What's going to happen? It's going to repel this one in that direction, and then the charge, the negatively charged, it's negative, it's going to attract that in that direction. But which one is going to win is this direction, which is left. Why? Because the electric field that is happening between these two, it's happening at a shorter distance, is going to be bigger than the electric field between these two, right? So the answer there is left. I hope I make sense, guys. The answer is A there. 1.9, it says the circuit diagram below shows four identical bulbs M, N, P, Q connected to the battery. The power dissipated by the bulb M is 60 watts. They say the power is 60 watts there, and it says the resistance of the connecting wire and the battery may be ignored. So now, having this circuit, let's look at the current here. Let's look at the current. The current will come from the positive terminal to the negative terminal. So the current will move in this direction. It's the total current there. Will move in this direction, and then when it gets there, there's a split. When it gets there, there's a split. The other current, it's supposed to split because there's a junction, but if you look at this junction here, there's no resistance at all, it's only a wire. And they told us the connecting wire and the battery, the resistance of the connecting wire and the battery may be ignored. So here, the current, when it gets here, there's no split, it will go straight here, right? It will go straight as it is. So it's that navy. I'll use the same color. So the current, what I'm trying to say, it won't go this way because here it's a short-circuited side. Well, because there's no resistance, the entire current will go this way, right? There will be no current that go this way, right? So the current will move there, and then when it gets to that junction there, if you look at this, as we are going in this way now, there is a current that will go, that will take this path, and there is a current that will take this path, because in this path now there is a resistance, in this path there is a resistance, right? Okay, let's use different colors now. So there will be a current that will go this way, right? This way, this way. Oh, come on, what am I doing? Don't go that way. So, and there is a split of the current that will go this way, this way, this way, this way, this way, this way, and then they meet there, and then it's a total current again. Are you noticing there? No current, no voltage is needed there, no power there. So this one, it has a 0 watts, 0 voltage, 0 current, right? Now it says the power dissipated by bulb 2, which is exactly this one, is what? Is 0. So the answer is A there, right? I hope I do make sense. Right, let's look at the last question in the multiple choice, guys. Right, it says the diagram below represent the three energy levels, which is X, Y, and Z. Here are the three energy levels, X, Y, Z. These are the energy levels. Now it says in a certain atom. Now the energy difference between Y and X is twice the energy difference of X and Y. So the energy, let's read it again. The energy difference between Y and Z is twice. Okay, so we're going to say 2E. So the energy difference here is 2E, right? And then is twice the energy difference of what? X and Y. So where is X and Y? X and Y, it's from here to here, right? So if it's twice, if the energy difference of Y to Z is twice the energy of X to Y, that means that this one is, if this one is 2E, this one is going to be 1E. So it will be just 1E, right? Okay, now it says here, if the wavelength of a photon emitted as a result of transitioning P from level X to Y is lambda. So the wavelength, guys, if you are transitioning from that, guys, if you're looking at this, this is the higher energy level, which is the top one. This is the higher energy level, this one. In this one here, it's a lower energy level, that one we call it, it's a ground state. So what is happening here, the electrons are transitioning. If they are transitioning from there to there, so that means they're coming from a higher energy level to a lower energy level, which is what we call that. So what we call that, it's an emission. It's an emission line spectra, right? But if they were coming from the lower energy level, which is the ground state, to the higher energy level, which is the excited state, the higher energy level, we call it, it's an excited state. So if they're moving there, we call it, it's a absorption line spectra. It's an absorption line spectra if they're moving to a lower energy level to a higher energy level. But in this case, we're going to focus on the emission line spectra. Let's read it again. If the wavelength of the photon emitted as a result of transition P, if you look at transition P, we're coming from a high energy level to the mid energy level, which means that the energy difference there, it's what? It's E, which is that transition P there from X to Y, right? And then it says, then the wavelength of the photon emitted during the transition Q from X to Z, and then they said the wavelength, if the wavelength here is just lambda from X to Y, but they're asking now from X to Z, which is the transition Q, what is the wavelength there? What is the wavelength there? Guys, we can associate the wavelength with the energy from the formula that says energy is equal to C over lambda. There's that one. If you see there, the energy is inversely proportional to the wavelength there. So the greater the energy, the smaller the wavelength. The smaller the energy, the bigger or the longer the wavelength there. So guys, from transitioning from higher energy level to the lower energy level, the energy difference is 3, because it's what? It's these two, it's going to be 3e. So that means the energy has gone up by 3 times. So it simply means that the wavelength will decrease by 3 times. So if you look guys here, the energy levels here from X to Y, from X to Z, there the energy level is 3 plus 2, which is the energy difference is 3. So the energy is 3 times. So if the energy has increased 3 times, or it's 3 times, so the wavelength is going to decrease what? 3 times. So which is just going to be 1 over 3. So the answer here is D. Guys, I hope I do make sense by that. I tried. Guys, we are done with the multiple choice there. So we're gonna go to question 2 now.